Welcome to all. Today we are going to see about the gratings. So first let us see what is or how the gratings work. This grating involves the interference among multiple signals originating from the same source. That is, we'll be having a single source. From that source, different optical signals can come out, but they can have different relative phase shift. Yet another device is known as etalons. In etalons, multiple signals are generated by the repeated traversals inside a single cavity. Inside a single cavity, it can move a number of times, and by it, multiple signals are generated. Such devices are called etalons. Now consider an electromagnetic wave of frequency, angular frequency omega, propagating along the z direction, and so we assume it has a dependence on z and time. So it is represented as cos omega t minus beta z. Beta is your propagation constant. Then it depends upon the medium. That is, depending upon the medium, the propagation constant varies. Next, the phase of the wave is given by omega t minus beta z. That relative phase shift. How it is achieved means if they move along two paths of different length. If the path length or if two signals is having a path difference means it will have relative phase shift. Then what is the use of these gratings? These gratings can separate light into its constituent wavelength, and it can also be used as demultiplexers to separate the individual wavelength. It is also used to combine the wavelength, so it acts as a multiplexer. So this is the diagram of a transmission grating, and this is your reflection grating. This theta I is the angle of incidence, and the incident angle is composed of lambda 1 and lambda 2. That is, two signals are present, we assume. This is your diffracted angle. Theta d is a diffracted angle. For lambda 1, it is the diffracted angle is theta d1, and for lambda 2, the diffracted angle is theta d2. This is your transmission grating. This is your reflection grating. This is your grating plane. These lines are your slits. The slits are very narrow, and this is your imaging plane. Next, so in the grating, a number of narrow slits can be placed, and they are spaced equally. So this is the number of narrow slits. The spacing between them is equal, and that plane is called grating plane. So this plane is called grating plane, we say. So what is the spacing between the slits? So equally spaced, we say. So the spacing is equal between the adjacent slits. So that spacing is called pitch of the grating. Now assume we are having a source. The light from the source is allowed to pass through these slits. So these slits will transmit the light. Since all the slits are very narrow, the bending of rays, that is diffraction of rays, occurs, and the light passing through the slit spread out in all directions. So due to diffraction, that is, the spacing is very narrow. So that is, the opening of the slit is very narrow. So by the phenomenon of diffraction, the light spreads out in all directions. So primarily we had a source. From that source, light has been transmitted by the slits. So now all these slits act as a secondary source of light. Next, another one plane. That is another plane known as imaging plane. So where it is placed means it is placed parallel to the grating plate at some distance. So at which all the light that is coming out of the grating plane, the slits of the grating plane, will interfere in the imaging plane. Next, consider any point on this imaging plane. That is a light coming, that is a different wavelength coming out of the grating plane will interfere at some points in the imaging plane. So when the interference interfering waves at a particular point or in phase, then constructive interference is supposed to occur and the enhancement of the light intensity for those wavelengths will be occurring. Suppose there is lambda 1 signals from all slits are coming out and interfering at a particular point in the imaging plane means, and they are in phase means constructive interference will be occurring and the intensity for that particular lambda 1 value will be high. But we are having a number of slits, so interference cannot be constructive for all wavelengths, and so when interference is not constructive, that light intensity at those points will be less. So some wavelength interfere constructively at different points and some will be destructively interfering at different points on imaging plane. So this grating can perform a function of separating a wavelength division multiplex signal spatially into its constituent wavelength. So, in order to collect those wavelengths, optical fibers can be placed at different imaging points to collect the light of different wavelengths. Suppose if diffraction is not occurring, what will happen? We would have light transmitted, reflected or transmitted along the dotted lines. See this. Suppose diffraction is not occurring means the light will be transmitted along this direction. If reflection is not occurring means light will be transmitting, or if diffraction is not occurring means light will be reflected along this direction. So it implies that diffraction is a phenomenon behind the operation of these gratings. So diffraction is the key to the operation of these devices. So that's why it is called as diffraction gratings. Multiple transmissions, that is more transmissions are occurring in the grating means that grating is called transmission grating. See here, it is transmitted. This is the incoming signal. This is the transmitted signal. This is one signal. This is another one signal. So this is called transmission grating we say. See, but here, this is the incoming signal. It is reflected. So it is called number of reflections is occurring. So it is called reflection grating we say. So when multiple transmissions are occurring in the grating, it is called transmission grating. If the transmission slits are replaced by narrow reflecting surfaces. So in a reflection grating, we should use a material so that reflection can occur. So at the slits some reflecting materials has to be placed. So the remaining area will be placed by non-reflecting materials. So the principle of operation of a reflection grating is similar to that of a transmission grating only. So we prefer mostly reflection gratings. Why means they are very easier to fabricate. When compared to the transmission gratings, reflection gratings are easier to fabricate and they are fabricated in a concave geometry. Instead of a plane geometry, they prefer concave geometry and the slits will be placed in the arc of a circle. So why we are going for this concave geometry? Because of this concave geometry, we will be using less elements, less number of elements, like less number of lenses, mirrors to form the overall device. So concave geometry is mostly preferred in reflection gratings. Thank you.